Okay guys, in this lab we are going to configure Ospf multi-area lab. We have three routers connected together. Router 1 and router 2 connected in area 0 through this network 10.0.0.0/24, and router 2 with router 3, which is in this network and area 1 192.168.10.0/30. So as you see, this is an area border router because it's one interface in area 0 and one interface in area 1. So this router is part of the two areas. It's called an area border router. We have also loopback interfaces of 1.1.1.1, 2.2.2.2, 3.3.3.3/32. So let's start the configuration of Ospf. Again, I don't cover any theory. There are a lot of books and other courses which you can learn the theory. This course is for people who have read the books and have done few courses, but they need the practical side to see the practical side of the configuration. So let's dive right into it, and let's start with router 1. We go to global configuration mode, and then in router configuration mode we'll use Ospf, and process ID is locally significant, so it can be 1 here, 2 in the other router, and 3 in the third router. It doesn't mean anything different like AGRP, which uses autonomous system number and need to be the same in all routers in order to form an agency. So let's start, and okay, router ID, we need the router ID. So router Ospf1. Normally in real world this is automatically assigned from the loopback interface or the highest IP interface, but since we don't have anything configured right now, this is that's why this error here. So let's continue, and now we should put the network statement, which is only this one and this one for this router. So network 10.0.0.0, and different from router RIP, which we have seen until now, we need to use a wildcard mask, and the wildcard mask can be taken from the subnet by extracting 255. So subnet mask is /24, and we have 255.255.255.0. so 255 minus 255 0, 255 minus 255 0, 255 minus 255 0, and 0 minus 255, we have 255 in the end. So sorry, 0.0.0.255. and as we know, Ospf, in order to work, needs areas. It's based on areas, so area 0, and again network 1.1.1, and this wildcard mask is 32-bit, so area 0. This is the loopback interface network which are going to configure, and let's configure the IPs. Interface loopback 0, 1.1.1, and 255. So interface fast Ethernet 0/0, IP address of 10.0.0.1, 255.255.255.0. No shut the interface. That's all for router 1. Now we should go to router 2 and do quite a different configuration, because we'll see now where router Ospf2 this time. Router ID, we need this. So router Ospf2. We see it's a different number, but it doesn't matter as it is locally significant and not globally significant. So let's go to network 10.0.0.0 and again subnet mask of 255.0.0.0.255, and this is in area 0 because this interface here. So now we have network 192.168.10.0, and we have a /30 subnet mask which is 000 and is 3 because the subnet mask here is 255.255.255.252. You should be comfortable with subnetting before following these labs, which I believe you are. And this time the area is area 1 this time. Also we have a loopback interface, so network 2.2.2.2.255.255.255, and we can put it in area 0. Now we should put the interfaces. Interface loopback 0, IP address 255.255.2.2.2 and 255.255.255.255. Then interface fast Ethernet 00, IP address of 10.0.0.2, 255.255.255.0, and no shot the interface, and again interface gigabit 2/0 this time. Oh, sorry, gigabit 1/0, and we see now that we have formed an agency with router 1. So let's see here. We have gigabit Ethernet, so IP address 192.168.10.1, 255.255.255.252. Now shut the interface, and let's go to router 3 now, the last router. And here I'm going to show you a trick, because when we do the networks here, we are not really advertising the network, and this is a point where many people get confused. We are just saying that if any interface we configure on this router falls under this network or this network, then it will participate in the Ospf agency. So in router 3, let's do router Ospf 3 now, and router ID now, router Ospf 3 network. I am saying now with this command, which is a shortcut 0.0.0.0 and 255.255.255.255 area 1. I'm telling all interfaces with any all interfaces that this router will have to participate in the Ospf neighborship. So now I configure the IP address of router 3, which is interface loopback 0, IP address 3.3.3, 255.255.255.255, and interface gigabit 2/0, IP address 192.168.10, 255.255.255.252. Now shut the interface, and we should see an agency forming, and we just see that is formed. And my favorite commands to show, it's show IP Ospf lib, which shows all the networks that we have learned, and we have learned from inter area the network of loopback address of router 1, loopback address of router 2, network of the area 0 in router 1, and our network. So we should be able to ping now 1.1.1, and we see it's successful. And also from here we can ping 3.3.3, and from here we can ping now 2.2.2. so we have inter-area OSPF communication. Another command I want to show you is show IP OSPF neighbor, and we see this is backup designated router, router 2, and that is, although we have a higher IP loopback interface, the designated router should be router 1 OSPF neighbor, because router 1 is the first one to have been configured with the loopback address, and that's why it's the designated router. Again, for theory you should follow other courses. I only cover the practical side. And another command is our favorite, show IP route, and we see now that we have learned, router 2 has learned this network from OSPF, also this network from OSPF. Let's see in router 1, show IP route, and we have learned this loopback address of router 3 interface, or this network, from inter-area OSPF. You see here, inter-area OSPF, and O means OSPF. So that's all there is to configuring OSPF. I will see you, to configuring multi-area OSPF, and I will see you in the next video.